Hi guys, it's Miss Brown speaking. Today we are going to continue talking about evaluating algebraic expressions, but today we are going to include fractions and decimals. So it is very important that as you go through your work today, that you remember first of all to use GEMDAS, looking for grouping symbols, then exponents, then multiplication and division from left to right, and addition and subtraction from left to right. In addition to that, we have to remember our integer rules. Now, our integer rules tell us how to work with positive and negative numbers. In addition to that, guys, we need to remember how to work with fractions, and we need to remember how to work with decimals. So these are all topics that have been covered in 5th, 6th, and 7th grade. And now we're going to have to use them all at the same time to evaluate these algebraic expressions. So I'm going to demonstrate a few problems for you. Our first problem is number 2, and it says 2 minus q to the third power. Use q equals negative 1/2. So the first thing I'm going to do is substitute in negative 1/2 for q. And I'm going to rewrite this as 2 minus negative 1/2. And I do need to put parentheses around that to indicate that I am raising that entire fraction to the third power. Okay, so let's look at GEMDAS. The first thing we're looking for are grouping symbols inside of which there is something to do. We do have parentheses, but in this occasion, they are not considered grouping symbols because there's really nothing to do to that fraction negative 1/2. So we're going to move on to E, which is exponents. And we do have exponents that we need to take care of. And the exponent is negative 1/2 to the third power. So here's where we've got to remember what that means. So off to the side, I'm going to do some scratch work. Negative 1/2 to the third power is equal to negative 1/2 times negative 1/2 times negative 1/2. Okay, so I'm going to go from left to right. The first thing I'm going to do is consider what negative 1/2 multiplied by negative 1/2 is. Okay, a negative times a negative is a positive. Those are those integer rules we have to think about. And then to multiply fractions, I multiply my numerators. 1 times 1 is 1. 2 times 2 is 4. So negative 1/2 times negative 1/2 is positive 1/4. But I still need to multiply that by this last negative 1/2. And I don't know if you notice, I just snuck that negative sign in because I forgot to write it earlier. Okay, so now we need to think about what is 1/4 times negative 1/2. This time we're multiplying a positive number by a negative number. A positive times a negative is a negative. And to multiply the fractions, I need to multiply the numerators or the top numbers. 1 times 1 is 1, and 4 times 2 is 8. So, going back to my original blue problem, I'm going to go ahead and rewrite the stuff on the outside of the box, 2 minus, but then we have figured out that negative 1/2 to the third power is equal to negative 1/8. So I am replacing the box with a negative 1/8, and I am putting parentheses around that negative 1/8 just to separate the subtraction sign and the negative sign. Okay, so I'm done with my exponents. Now I should be looking for multiplication and division. There is no multiplication and division in this problem. So the next thing I'm going to look for is addition and subtraction. And there is addition and subtraction. Actually, there's just subtraction right here. Okay. So notice I am subtracting. Our integer rules for subtracting integers tells us to add the opposite or keep, change, change. So I am keeping the 2 just as it is. I am changing the subtraction to an addition sign, and I am changing that negative 1/8 to a positive 1/8. So now I have 2 plus an eighth. And 2 plus an eighth is just 2 and 1/8. If you wanted to express that as an improper fraction, you could also express it by multiplying the 8 times 2, which gives us 16, and then adding 1 to it, which gives us 17. So 2 and 1/8 is the same thing as 17/8. You could also, if you wanted to, express that as a decimal. As a decimal, it's going to be 2 decimal, and I think an eighth is, I think it's decimal 125. Any of these answers are acceptable for me, Miss Brown. If you are on the end of grade test or even the check-ins, I don't believe that they will take the mixed number 2 and an eighth. Generally, you have to express your number as an improper fraction or as a decimal. So on the check-in or EOG, you would probably need to use 17/8 or 2.125. Okay, moving on to our next problem. Okay, well, that's not the problem I had intended to do, but I guess it's the problem I'm going to do right now. I'm going to look at number 7. Number 7 says 9/2 A minus 1/5 times B minus 12. Use A equal a third and B equals 2. So the first thing I'm going to do is to substitute in the numerical values for the variables. So that would be 9/2 times A, which is a third. Notice I used a dot to indicate multiplication. Minus 1/5 times B is 2 minus 12. Okay, so let's not forget our order of operations. We're going to look for grouping symbols, then exponents, then multiplication and division from left to right, and then addition and subtraction from left to right. So the first thing we are looking for is grouping symbols, and we do have grouping symbols, the parentheses. So the first thing we need to concentrate on is what is 2 minus 12. And according to our integer rules, when we have something such as 2 minus 12, we are supposed to add the opposite or keep, change, change. So now we have 2 plus negative 12, and our rule tells us to subtract those absolute values. So 12 minus 2 is 10, and we have to keep the sign of the number with the greater absolute value. Since negative 12 has a greater distance from 0, that's going to be equal to negative 10. So I'm going to go back to my original blue problem. I'm going to replace my box with a negative 10. So now we have 9 halves times a third minus a fifth times negative 10. Now notice I put the dot for multiplication. You could just as easily have used the parentheses to indicate multiplication. It's the same thing. Okay, so going back to GEMDOS, I don't see any more grouping symbols inside of which there is something to do. There are no exponents, so we are looking for multiplication and division. There are 2 instances of multiplication, so we need to go from left to right. So we are going to go over here and look at 9 halves times a third. And I am going to actually simplify before I multiply. And what I'm going to do is I'm going to divide this 9 by 3 and divide on the bottom this 3 by 3. So essentially what that gives me is 9 divided by 3 is 3 halves times 1 over, and 3 divided by 3 is 1. So it gives me 3 halves times 1 over 1, which is just equal to 3 halves. So I'm going to go and replace my box with 3 halves and then copy everything down, or the rest down, minus 1/5 times, I'm going to go ahead and use the dot, and negative 10. And I know I'm going to need to make that negative 10 into an improper fraction, so I'm going to go ahead and do that now. Negative 10 over 1 is the same thing as negative 10. Okay, so we are still looking for multiplication and division. We still have some multiplication to do right here. 1/5 times negative 10. So we're going to have to be careful here because A, we've got to deal with the fractions. And then B, we've got to remember our sign. We are multiplying a positive 1/5 times a negative 10. A positive times a negative is a negative. So our answer when we replace the box needs to be negative. I'm going to go ahead and multiply across. 1 times negative 10 is negative 10, and 5 times 1 is 5, and negative 10 divided by 5 is negative 2. So I'm going to replace that box with a negative 2. So now we have 3 halves minus negative 2. Okay, so there's only one thing to do, and that is the subtraction. However, we have to remember our integer rules. When we are subtracting positive and negative numbers, remember we need to add the opposite or keep, change, change. So I'm going to keep the 3 halves as it is. I'm going to change the subtraction to addition and change the negative 2 to a positive 2. Okay, we still have another issue. And the issue is that we are trying to add a fraction to a whole number. So we have options. We can either make that whole number into a fraction, or we can either turn that fraction into a decimal. I choose to turn the fraction into a decimal. 3/2 is the same thing as 1.5. So I have 1.5 plus a positive 2. And 1.5 plus a positive 2 is just equal to 3.5. And that is our answer. I hope that I have one more example here to show you. Let me see if I can find it. Here it is. So this example says 0.5 plus h divided by k minus 1. Use h equals 1 and k equals 2/3. So the first thing we are going to do is to replace the variables with numerical values. So that would give me 0.5 plus h, and h is equal to 1. All of that is over or divided by k, which is 2/3, minus 1. Okay, so now we are ready to think about GEMDAS. So we are looking for grouping symbols. Most of my kids would look at this problem and say, Miss Brown, there are no grouping symbols. But that is incorrect. If you look at the note sheet I gave you about order of operations, it states that this division line in a fraction can act as a grouping symbol. And what's actually happening is it's grouping the terms in the numerator and the terms in the denominator. Okay, even though you don't see that up here, it's implied that the top and the bottom is grouped together. So yes, we do have grouping symbols. So we need to go ahead and evaluate those. We are going to look at the numerator first. We're going top down, which is the same thing as going left to right, guys. Decimal 5 plus 1 is just equal to 1.5. So I am going to replace my box with 1.5. And then I'm going to copy down everything else. Divided by 2/3 minus 1. Okay, I'm still working on grouping symbols because I need to evaluate these terms in the denominator. And I have to be careful here because we need to use our rules for integers. So notice this says 2/3 minus 1. Our integer rules tell us when we subtract, we need to add the opposite or keep, change, change. So I'm keeping the 2/3 as it is, changing subtraction to addition, and changing that positive 1 to a negative 1. So now I have 2/3 plus negative 1. If I look at my integer addition rules for adding a negative and a positive, they tell me to subtract the absolute values and keep the sign of the number with the greater absolute value. So the sign of the number with the greater absolute value is negative. Negative 1 is a farther distance away from 0 than 2/3. So my answer is going to be negative. Now I need to subtract. But again, we have a slight problem. One number is a fraction, the other number is a whole number. A lot of kids would try to turn that fraction into a decimal, but that's not going to work for us because 2/3 as a decimal is decimal 6 that repeats forever, and that's going to give us a number we can't work with. So the better thing to do would be actually to turn that whole number into a fraction. Let's think about 1, okay? Isn't 3 divided by 3 the same thing as 1? Yeah? So we can think about this as 2/3 plus negative 3/3 because 3 divided by 3 is just 1. And now we're going to subtract 3/3 minus 2/3 gives us 1/3. And remember, it must be negative because that -1 or -3/3 has the greater absolute value. So I'm going to go back to my blue problem and replace that pink box with a -1/3. So now I have 1.5 divided by -1/3. Okay, the only thing left to do now is division. However, we have a slight issue. Okay, so we are trying to, let me write that out in a different form. It means the same thing. We are trying to take 1.5 and divide it by -1/3. Okay, let's remember our integer rules. We have a positive number divided by a negative number. So our answer, whenever we get that answer, is going to be negative. I'm just going to put that negative sign there so I don't forget it. But our main issue is that we are trying to divide a decimal and a fraction. And we're not going to be able to do that. We either need to turn the decimal into a fraction or the fraction into a decimal. Again, turning that 1/3 or -1/3 into a decimal is not going to be possible because 1/3 as a decimal is just decimal 3 that repeats forever. And we can't work with that number like that as a decimal because that 3 never stops, okay? So it's going to be better to turn 1.5 into a fraction. Here's where we have to remember what 1.5 means. Does that not mean 1 and 1/2 divided by -1/3? And then I need to turn that 1/2 to an improper fraction. So now I'm following my division rules for fractions, okay? So I need to go 2 times 1 is 2, plus 1 is 3. So that would give me 3/2 divided by 2 divided by -1/3. Okay, so according to my fraction division rules, I need to multiply by the reciprocal, also known as keep, change, flip. Okay, but the correct math way to say it is multiply by the reciprocal. So I am leaving that 3/2 as it is. I'm going to change division to multiplication, and I'm going to flip that 3, the 1/3, to be 3/1. So the reciprocal of -1/3 is -3/1. And now I am ready to multiply across. 3 times 3 is 9, and 2 times 1 is 2. Don't forget that negative sign. So my answer is -9/2. If I wanted to, I could express -9/2 as -4.5. I could also express -9/2 as -4. 4.5. These all mean the same thing. Alrighty, so good luck with your math today. Thanks. Bye-bye.